Okay, so question number one, we will talk about question number one. They're saying that the figure 1.1 shows a section of a river where a water is flowing from right to left, mean water is flowing from this side. And the speed of water is given this one. A swimmer starts at P, swims as a constant speed of what? 0.72 meter per second to the water, right angle to the current. Now see here. So this is the direction of the water. For example, water is flowing like this. And then the person is swimming like this. So in which direction he will go? So that for that we have to find. So this is 0.54 and this is 0.72. So now the resultant vector is this one. If you see the resultant vector, so this we have to find the magnitude. If you want to do it in a mathematical way, so this is the opposite, this is the adjacent, and this is the hypotenuse. So if you want to find the hypotenuse, you have the Pythagoras theorem. That is what? C square equal to A square plus B square then square root. So here you have to find C. So simply you can say 0.72 square plus 0.54 square, then take the under root. And when you will do this one, the answer you will get 0.90 meter per second. So that is here 0.9 meter per second. Now they ask about the direction of the velocity, on which direction you will go. So for direction, you know that you need a formula that is tan theta equal to sine over cos. Okay. So here, once again, instead of tan theta, so what you will write here, tan theta, here it will be opposite divided by adjacent. So here, if you write this one, so it will be 0.72 over 0.54. If I take this one here, so it will be tan theta equal to 0.72 divided by 0.54. So, but we need only theta, so it will be tan inverse 0.72 divided by 0.54. So if you will do it by in this way, so the answer you will get, that will be theta equal to almost 53 degrees Celsius. So this is the first part how you will do this one. After that, the second part, they're saying after 1.5 minutes, the swimmer reaches the point Q. Calculate the distance between P and Q. So for that, you need you can say the formula once again, that equal to what we said, if the speed is constant, because they said that moving at a constant speed. So that we have find already. So find the formula. Normally speed equal to distance over time. But when you need distance, it will be speed multiplied by time. So time is already given. If you see time, time is 1.5 minutes. But if you convert it to second, so it will be 60 second plus 30 second because a half minute. This is 60 and this half 30, so total is 90 second. Now use this one here. So here you already found the answer, that is speed is 0.90 and time is 90. So when you calculate it, it will be almost 80 meter this one distance. Now explain that the swimmer is crossing the river. His action produce a constant forward force on his body. Explain why the moves at a constant speed. So when the swimmer is you can say moving in a swimming in a river, he is applying two forces. One force, the forward force, is applied by his body. Forward force applied by his body, and the opposite force or the force which is working against that one is a friction from water. So if these two forces are equal, if the forward force equal to the friction
Mm-hmm.
force, then it means that no resultant force. So if the case comes like this, the object always move in a constant speed if the forces become balanced. So due to that, this moves in a balanced speed, the balanced speed. Now you can listen to me.
Yeah, yeah.
Okay. Now we have the question number two. In question number two, he's saying that figure 2.1 shows a motorcyclist accelerating along a straight horizontal section. So you can see this is a horizontal section. The motorcyclist and motorcycle has a combined mass of 240 kg. On the straight horizontal section of the track, the motorcycle accelerates from rest to this one. So if you talk about initial velocity, that is zero because this sets from rest. After that, they have given you acceleration, that is equal to how much? 7.2 meter per second square. And they have given you the time also. They said that 5.3 seconds. So what he need here, they need the final velocity or speed. So you have the formula for acceleration. Acceleration formula is that acceleration equal to the final speed minus initial speed divided by time. So now, if you talk about this one, we need what here? Final speed. In other words, if I want to write equation in a simple form, for example, for initial I use u, for final I use v, for acceleration I use a. So I can write this one a equal to v minus u divided by t. But now we have to find this one. So we have to take all the thing other side. So it will become a multiplied by t v minus u. Or if I bring the u on also the other side here, so v equal to v, u plus a times t like this. So this is the speed now. So if you use this for same formula here, v equal to u plus a times t. So now what is u? We already found that was 0 plus acceleration. We said that 7.2 and multiply by the time, that is 5.3. If you will multiply both of them, so you can get the answer if you have the calculator.
38.16.
30.
38.16.
So 38.60, or you can write also
16.
30,
No, no, no. 1
uh,
6.
16. Okay. So this is the meter per second. This one.
Okay.
After that, part B, they said that calculate the resultant force of motorcyclist. No, see, so you know that we have the equation that force equal to mass time acceleration, or this formula written like this: F equal to mass time A. So they have given the mass, the total, that is 240 kg. Acceleration they already given to you 7.2. So when you multiply them, what you will get?
1728.
1728 Newton. That's the
Yeah.
force. Got it?
Yeah, yeah.
Now they're saying at the end of the straight section, the track remains horizontal but bend the right. You can see this diagram if you go back here. You can see the road from here, then it start bending.
Hmm.
Can you see?
Yeah, yeah.
It's horizontal. It's not mean coming down, but just like circular path. It's from here changing the direction.
Okay.
Okay. When the motorcycle reaches the bend, he travels around the bend in a circular path at a constant speed. So the in here, for example, here she is 20 meter per second. Here also 20 meter per second. Here also 20 meter per second. Means the speed is constant. But we studied that when the direction is changing, so velocity is also changing. So because velocity depend on direction, it means in term of speed, the speed is constant, but in term of velocity, velocity is changing all the time because direction is changing all the time. So in that case, so acceleration is also produced because the velocity is changed. Now see the question, velocity is a vector quantity. State a vector, how a vector quantity differs from this one. So you can write the definition that the vector, what vector needs? Vector needs magnitude plus they need unit plus they need direction. Scalars, they need only magnitude and unit only. So vector quantities, they need the direction also. Describe what happened to the velocity of the motorcyclist as he round the bend at constant speed. Yes, as I told you that velocity will change. The speed is constant, but the velocity will change. Why? Because the direction is changing. So you can say that velocity will be changed because direction is changed. Explain why there must be a resultant force on a motorcyclist as travel round. Now, when anything changes the direction, so it needs a force. Without a force, you cannot make it. Because when you want to make acceleration, what is acceleration? Change in velocity. Change in velocity means it needs a change in direction. So here, if you apply a force, you can change the direction. Otherwise, you cannot change. If the object is moving in a circular path, and if you want to make a bend, so you have to apply a force. In a circular path, if you remember, we talk about centripetal force. So when
Yeah.
object is moving in a circular path, a force acting always toward the center, that's known as centripetal force. So whenever you want to make a change in velocity or in speed, so you have to provide an external force. Got it?
Mm-hmm. So for 2 marks, what's the suitable answer for that?
I can share the marking scheme with you, but I just want to understand, you will understand this one. Got it?
Mm-hmm.
So in the marking
Okay.
scheme, there are options are given. You can write any two out of that. Got it?
Okay.
So first thing you can say the external force is required because the acceleration is produced due to the change in velocity or change in direction. Understand? Then you can say
Mm-hmm.
the the direction due to the velocity will change. So acceleration is produced, and acceleration produced only when there is a resultant force. So like this, the answer is given there. You can find, but better thing you will understand that one.
Mm-hmm.
A rubber balloon is inflated with the helium and sealed so that no helium gas escape. The balloon is positioned immediately below the ceiling in a room. So, for example, you have this room. This is internal, and here you have the balloon. It has helium inside. Helium is you can say a lighter gas, so it will stick with the ceiling, go up. Heaters are switched on and the temperature of the air in the room increases. So here you switch on the heater down and temperature of the room will increase. When the heater first switch on, the temperature of the air immediately below the ceiling increase more quickly than the temperature in the air rest of the room. They're saying that, let's say before all the temperature has 25 degree, all the room has the same temperature, 25-degree here, 25-degree here, 25-degree here. But as you switch on the heater, so here temperature near the ceiling, it will become, let's say, 32 very quickly. Although still here you have 26 something. So why the temperature near the ceiling is increasing too much? So answer is really simple that when because heater is heating the gas near air near to it. So when the air become hot, it become less dense, it rises up. So all hot air will come and you can say gathered at near the ceiling. So you will feel
Mm-hmm.
that the ceiling temperature increase too much. And after that, again the hot gas will go up like this. So it's like a current. So slowly, slowly, all the room will get the same temperature. But in the beginning, because the air become hot, so it will go and stay near the ceiling. And in the beginning, you feel that ceiling temperature is much higher than the temperature rest of the room. Got it?
Convection.
Yes, convection. So you can write here that the when the heater switch on, the air become hot and rise up due to less density. So hot air gathered in the upper part of the ceiling so that it has higher temperature as compared to the other.
Mm-hmm.
Got it?
Yeah.
After that, the temperature of helium in the balloon increases as the rubber stretches. The volume occupied by the helium increase. They're saying that if you have helium gas inside the balloon, so that that gas become hot, so it will apply a pressure on the balloon. And as a result, you will find that the volume of the balloon will increase. Maybe the size become like this. Got it?
Mm-hmm.
Now, state what happened to the motion of the helium particle as the temperature increases. So we studied that when a heat is supplied to the gas particle, so the kinetic energy of the gas particle increases and gas particles move faster. When they move faster, they collide with each other and also collide with the walls of the container or the balloon, and they apply a pressure on the balloon. Got it?
Mm-hmm.
Okay. Now, here, as the rubber stretches, the volume of helium increases, the pressure of the helium remain constant. Explain in terms of particle how of helium how the pressure of the helium remain constant. Now it's very simple. So for example, now before this much the volume, you can see the red one. So the particles are moving in a constant speed. But when you heat it, then particle move faster. So automatically the pressure inside the balloon will increase. If balloon will increase the volume, then that pressure again become less because now they have more space to move. If the balloon will not increase the volume, then pressure will increase inside because there are space is the same, volume is the same, but particles are moving faster. But when it is made of rubber and it will stretch itself, it will increase the volume. So pressure again remains same. Got it?
Mm-hmm.
Okay, question number 4. A student investigate the efficiency of a filament lamp. Figure 4.1 shows the filament lamp with its bulb immersed in water beaker. So here you can see it is water beaker. Only the glass part is in the water. All the other insulating mean the wire they're outside. And here you have a thermometer. The reading on the thermometer is 19 degrees Celsius. Only the glass of the lamp is contact with the water and the electrical connections are completely insulated. The lamp is switched on. At the end of the experiment, temperature of water become 21. So it means what how much the temperature change if you see. So it will be 21.5
2.5.
minus 19. So it will be 2.5.
5.
Got it?
Mm-hmm. Yeah.
The mass of the water in the beaker is 600 grams and the specific heat capacity of the water is this one. Show that the increase of the internal energy is 6,300. So you know the formula energy, change in energy or delta is equal to m times c times delta theta, I mean change in temperature. So, what is the mass of water? It is given already, that is 600 grams. But we need in kilograms because here the unit is kilogram. So, it will be
Zero
zero
point
point
six.
0.6. Then multiply specific heat capacity that is given 4,200 and change in temperature is 2.5. So, what is the energy?
Okay. Yeah. 6,000 and 3,000 joules.
Got it? So, now we have
Yeah,
proved
yeah.
that they are same. Got it?
Yeah.
Okay. Now, question number 2. In the experiment, the lamp is switched on for 500 seconds, mean the time is 500 seconds. Then the power supply to the filament that is 13 watts, so power equal to 13 watts. The useful energy of the lamp is transferred as light. The energy that increase the temperature is a waste energy. Determine the maximum possible efficiency of the lamp. If you see the efficiency of the lamp, so what is the formula or efficiency? Efficiency is you have useful output divided by total input multiply by 100%. So this is the, you can say, the have the total. Now, how much energy is supplied? Now the question comes, how you can find the useful output? They said that it is as a transfer of light. All other is a waste which use the water. So how much energy is used to heat the water? That's the thing you have to find. So for that, first of all, you have to find the useful amount of energy. For that, what you will do, you have different formulas to find the energy. For example, the one formula you are using, energy equal to power times
PT.
time, PT.
Yeah.
So here power is 13 and time is 500. If you multiply it, what you will get?
6,500.
6,500 joule. This is the total energy supplied by the to the bulb. From this is the total. From this, how much is going to the water? That is this one. Got it? So which is going to the water? What is that? Waste. And what is useful? Which is going to the light. So how much
Yeah.
left then going to the light?
200.
200 joule. So you can use this one equation again, the same formula. So you can say efficiency equal to what is useful, that is 200. What is the total?
Mhm.
That is 6,500. Multiply 100%. What you will get?
3.1, 3.17.
3.1%. So that is the efficiency. Got it?
Yeah.
Now the efficiency of the lamp is less than the value determined in point. They're saying that, okay, we found the efficiency should be 3.1%. But actually, when you will find that it is less than then, maybe you will get 2.2% like this. Why? What is the reason behind that? So, what can be the reason? What do you think? Because some of the heat is lost, some of energy is lost from water to air. Got it?
Mm-hmm.
So, and maybe some of the heat is transferred to the internal structure of the lamp inside. So, that is one of the reasons.
From the water to what?
Water to the air,
Uh-huh.
because when the water become hot, so the it can go to the, you can say, air also. Question number 5. The figure 5.1 shows a block ABCD. You have A, B, C, D has a refractive index n equal given 1.5. The block has one curved side AB. They are talking about this side. And the three side BC mean this one. And then CD this one and DA this one. Any confusion?
No.
Okay. There are right angle at C and D. The curved side AB is 1/4 of the circumference of the circle that has its center at P. They're saying that this curved part, it is just like the quarter. Quarter means fourth part. So it means if you add three more parts, so you can get a complete circle. One part, two part, three part, four part. Got it?
Yeah.
Okay. Now the ray of monochromatic light enters the block through the curved side. So from here, the monochromatic light is coming and strike the BC at P. So from here it's coming and then it's coming straight and at BC hit here. The some light emerge into the air and some is reflected. You can see some is coming here and some is reflected. State what is meant by monochromatic light. Monochromatic light means the light with single frequency. Light with one frequency, that's known as monochromatic light. Light with single frequency. Single frequency light. Got it?
Mm-hmm.
Okay. Now we'll see the next question. Explain. I'll make it smaller a little bit. Okay. Explain why the ray of light does not change the direction when entered the block through side AB. They're saying why it's not changing the direction here, why it's coming straight. If you remember, we said that when the ray of light enters through the normal, for example, this is a glass and this is a normal line. So when the ray of light enters along the normal, so it will not change direction, it will pass through. No refraction. And in a circular shape, all the angles are right angle. So if you have a circular glass, if the ray of light will enter from any direction, it will go straight. It will not change its direction. That is the reason here it's not changing the direction. Any confusion?
No.
Okay.
So
So you
we
can
can
say
say,
that, you can say here
uh-huh.
the angle of incidence here. So you can say angle of incidence. It is means I, it is zero. So angle of incidence is zero. It means it is coming along the normal. So you can say incident ray entering along north. Got it? So no refraction. Any confusion?
No.
Okay. Now show the critical angle C for the refractive index is 2.2 is 42. You have to show the critical angle. We studied about the critical angle. Critical angle have different formulas. Okay. So one of them, the critical angle equal to refractive index equal to 1 over sine C. But here, if you want to rearrange, it will become sine C equal to 1 over n. Or if you want to find only C, so it will become sine inverse 1 over n. So here, sine inverse 1 over n means 1 over 1.5. Can you solve it?
Okay. Sine inverse 1
1
over
over
1.5.
1.5.
Yeah. Almost 42. 41.8.
Okay, so almost that one, so that's fine. Got it?
Mm-hmm. Okay.
Now figure 5.1 shows that the angle between the ray AP theta, where line AP is a right angle to BC, the angle theta increased to 45. State and explain what happened to the light that strike at P. So now what is the critical angle we found? That is 42. Remember, we just found it now.
Yeah.
So, and we said that if the incidence angle will increase the more than critical angle, so the ray will go for total internal reflection. Some of the part will go like this and all other will reflect back. So it's the same thing here. You can say all light is reflected, or you can say the total internal reflection.
Okay.
And what is the reason for that? With what you can say, the angle of incidence mean angle I. So how you can say it is greater than the critical angle, so that it is happening.
Okay.
Got it?
Yeah.
Okay, so when theta is 40, does that happen to the reflected right strike on CD? Yes, so you can say that right it will reflect. Here till here is this one, and here it will reflect. The same thing here. They're talking to reflect. Some of them will,
Reflect.
huh? Reflected.
Reflect.
Reflected because angle is
Uh-huh.
45. So it is more than critical angle. Total reflection.
Mm-hmm.
Reflection means if like this, it will reflect back. Total internal reflection. Now you have question number 6. Question number 6, that a mobile phone or cell phone network uses the microwave, and though microwave has the frequency is given this one, this is F, transmit the received signal. The speed of microwave, you know that all the electromagnetic waves move with the speed of light. That is 3.010 raised to power 8 meter per second. Calculate the wavelength. What is the formula of speed? Speed V equal to frequency multiplied by wavelength. So here you need wavelength. So wavelength will be speed over frequency. So what is speed? 3.010 raised 8 to 10 power meter per second divided by what is the frequency? 1.9 10 raised to power 9. So when you solve it, what you will get, please can you check?
Okay.
So in question number 6, we were talking about the to find the wavelength, the frequency is given, the speed is given. So formula is speed equal to frequency multiplied by wavelength. And if you want to calculate the wavelength, it will be speed over frequency. If you do this one, speed is 3.010 raised to power 8, and the frequency is 1.9 10 raised to power 9. When you solve it, so if you see, you can just simplify this one. So it will be 3.0 over 1.9, 10 raised to power 8 minus 9. So if you calculate it, so the answer is 0.0 divided by 1.9. It will be, answer will be 0.1578, something like that. And wavelength, it should be the in meters, smaller. Okay. After that, state two reason why microwaves are used for mobile phones. So, number one, they need short antennas. Number one, this one. Number two, they have more penetration power. Penetration power. They can pass through the walls and other things. More penetration power. Can pass through walls. That is. Now, all mobile phones or cell phone networks are use digital signal to communicate with the phone. Describe with the aid of diagram how digital signals differ from analog signals. So if you talk about in terms of the diagram, so if you remember, we discussed about digital and analog diagram. So for example, if I want to draw for digital, so in digital we did like this. Means digital has only two, 0 and 1. 0 means low and 1 mean high, or 0 mean off and 1 mean on. They don't have any other. They don't have zero point 0.5 or 1.5, nothing. Only two values. You can see here either it has 1 or 0, or here again 1 or 0. But if you talk about analog, you'll find like this. The values are changing like this. It means the values are changing up and down. So this is the main difference. You can draw these two diagrams. This is for digital and this is for you have analog, this one. And you can write here in the question that the digital value, the digital signal, they have only two values, 0 and 1. 1 and 1 mean on and oh, this 0 mean off. And secondly, you can say that they you can say in series, you can say in analog, so the value of the signal range is sometime high, sometime low, sometime medium, like this. So they have just like a change. Next, state two advantages of digital using digital signal rather than analog signal. So lot of, you can say the data transfer faster. Then other thing, you can say data can be compressed. And then you can say the signal can be transferred over long distance. Got it? So like this, there are a lot. I will share the marking scheme with you so you can write any two from that. Is it clear? Now you have question number 7. Question number 7, figure 7 point shows a circuit that contain a battery. This is the battery. Then a switch. This is the switch. A voltmeter. This is a voltmeter. And three resistors of 40 ohm. So this is also 40 ohm. This is also 40 ohm. And this is also 40 ohm. Okay. So this is R1, R2, and R3 resistors are there. Okay. What is the first one? The switch is open and resistor R1 and R2 form a potential divider. So now if the switch is open, this one, so it means R3 is not active. So only the current is coming from this side and coming like this and then going to this side. So here, now these two are working as a potential divider. What is a potential divider? Potential divider is an arrangement or a setup which will divide your, you can say, potential into two or more than two, or depending on number of resistors you have. For example, here you have, let's say, 15 volts. So now it will divide it 7.5, 7.5. So now if any machine needs 7.5 volt and you don't have, you have only 15, so by using these, you can say, the resistors, you can produce 7.5 and attach that device here so it can get 7.5. So this is a potential divider, mean divide your potential into the two or three parts. So first one, describe what is meant by potential divider. You can say that a setup or apparatus which will divide or split, divide, shares the potential difference, or you can say EMF. Understand? So this one. So here you have to write this one. After that, now the reading on the voltmeter is 7.5. If the reading here is 7.5 volt, got it? So what will be the total EMF of the battery? So as we said that both are 40 ohm resistors. So this potential, if there is any, you can say, value or the any potential difference, if the resistors are same, so it will divide equally. Means if there is 7.5 volt, here also 7 volt. So it means total will be how much? 15 volt. Now the switch is closed. Now if the switch is closed, mean the shape will be like this. It means now you have three resistors. So you can say that R3 is parallel to R2. Then these two parallel, and then this is in series. Calculate the results of the complete circuit. So again, if you want to find complete, so first of all, you have to find the combined resistance for these two. Whatever the answer will come here, then you will add in this one. So to find this one, so you have a formula. If you want to find combined resistance of R2 and R3, you have a formula. R1 times R2 divided by R1 plus R2. But here, instead of R1, R2, you have R2 multiply R3 divided by R2 plus R3. For example, that is what 40, because all they are 40. This is also 40, this is also 40. So 40 multiply 40 divide by 40 plus 40. So it will be above divided by 80. So if you will solve it, so it will be 2, so I think 20 ohm. So for these two combine is 20 ohm. But this one answer and this one, they are in series. So in series, you know that resistance equal to R1 plus R2. So here R1 is here, that is 40. For R2, we found that is 20. So it will be 20 ohm. So total is 60 ohm. So answer here is 60 ohm. So you can show these, this one and plus this one, both. Okay. After that, they're saying the reading on the voltmeter. So if you do this one, what will be the reading on that voltmeter? So it's very simple. If you see again here, so now what we did for both of them, what we said here resistance what 20 ohm and here resistance is what 40 ohm. This is again 15 volts. We already calculated that one. But right now it will divide in this way, means more resistors, more voltage. So it will be like this. Here will be 10 volts and here will be 5 volts. So then total again 15 here. So this combination will work here. Question number 8. Question number 8, they are talking about a transformer. You know the purpose of transformer. Transformer is used to step down or step up the voltage. If you see the transformer, so it consists of two coils. So the first coil is known as primary coil and this is known as secondary coil. Why this is primary? Why? Because here you the input, and why it is secondary? Because this is for output. If input here this side, so it will become primary and this becomes secondary. So there is no rule that always left is primary or right is secondary. It depends on input and output. So they said that how does a transformer works? All the time they ask this question. So I will share the answer with the as a mark scheme, but try to understand. When the current enters at primary coil, so it produces a magnetic field in the primary coil, and that magnetic field is what
Can you
alternating. Magnetic field is alternating. Why? Because transformer work only on AC voltage. So this magnetic field will produce that is alternating. So then this magnetic field, alternating magnetic field, transferred to the secondary coil with the help of iron core. This is the iron core. Then when this voltage will transfer to the secondary coil,
listen?
coil will also produce a changing magnetic field. So due to these changing magnetic field, the voltage is changed. So
Listen.
like this transfer. Yes,
Can you hear me?
yes, I can hear you.
Alhamdulillah. Okay. This question is clear, but if you return to the previous one,
I recorded everything. I sent you the link. Or still you have a question?
yeah, I have a question again.
No problem. Question number 7.
Yeah, 7C.
Yes.
You said you divided the voltage between the resistances. You said 10 and 5.
Yes, because due to the ratio. Because whenever you have the ratio, so ratio means that the how the voltage will be divided. For example, now the total voltage is 15. Got it? And total resistance is 60. Got it? This is
Mhm.
the total. So if you want to make this one, so you can say, let's say R1 and the total R we found, it will be equal to V1 and V2 we found here. So here, what is the R1 we said? That we said that is 40. And here is what? 20. So what is the ratio I have? Ratio will be 2 over 1. Same way, the voltage ratio will be 2 over 1. So if total is 15, so here will be down will be 5, upper will be 10. So this is how they find it.
Mm-hmm.
Got it?
Yeah.
So just like a proportion, comparing that.
Mm-hmm.
Can we move now? This clear?
Yeah, yeah, yeah. This one is clear. Yeah.
So can we move to B, or you know already this one?
I know this one, and I was calculating the current. This one is
Uh,
3,000
how,
turns.
the how much? 3,000
Three
turns.
thousand. Yeah.
Okay, so for that, simply you can say what is the formula you are using?
VP over
NP
VS
over NS equal to
equal to
VP over VS.
VS.
Okay, so what he need here, number of turns of primary. Okay,
Yeah.
so it will be formula will be
It will be VP times NS over VS.
VP times NS divided by VS. Got it?
Yeah. Yeah.
So what is
VP
VP?
is 220,000 volts.
Multiply what is NS
440,
divide
450
by,
divided by 33,000.
got it. So what's the
300.
answer you will get?
300 tons.
1010, two zeros, two zeros. Okay. So how much it will be?
3,000.
3,000. Next,
Yeah. Yeah.
the current.
Yeah. The current.
Current, you know, what is the current formula? Different P equal to I times V, and I equal to P over V. This is one of that one. So power they have given, that is how much? It means 77
77.
multiplied 10 raised to power 6. Yes.
Yeah. Megawatts.
And voltage is how much? The primary. At primary, what was the voltage? 220, this one. So when you get the answer, what you will get? Are you with me? Hello. Okay, so you can do it. 77. Here you put 1, 2, 3, 4, 5, 6, 4, 35. Example, here you have four zeros with four zeros. So you have 7,700 divided by 22. So I think we can check the answer. No, I cannot hear you. Okay, just calculate the answer with the calculator. So you'll get here. So this is how much? 24 zeros are there. So four zeros are moved from here. So this will be done. So it is almost somewhere 350 ampere, if I'm not wrong.
Can you hear me now?
Yes, I can hear you now.
Okay. It's 35.
How 35? Can you do it?
Yeah. 77 million
Yes,
over 220,000.
yes,
Yeah, I think I have a mistake here. Yeah. 350.
yes, 350 ampere. Got
Mm-hmm.
it?
Yeah, yeah.
Okay, now question number 9. In the question number 9, they're saying that figure 9.1 represent all the particle in a neutral atom of radioactive isotope X1. So there is a neutral. Neutral means atom. Neutral atom, what does it mean? Number of protons equal to
Equal to the
number
number
of
of neutron
electrons.
electrons. Yeah.
Electrons. So here see how many electrons are there.
5.
So how many proton will be there? 5. How many
Yeah.
neutron will be there? The center is proton plus neutron. Center is proton plus neutron.
Neutron.
So if you see the center here, so
Neutrons
how
are
many
12.
so how many protons
No,
are
no,
there?
7.
5. These
7.
are why. So how many neutron? 7. Got
Yeah.
it? So
Mm-hmm.
how many neutrons are there? 7.
7.
And what is the explanation here you can say? First thing you can say number of proton equal to number of electron. This is the first one. Got it? And after
Yeah.
that, the nucleus has proton and neutron. So it means that the dark dots, they are what? Neutrons. The white ones are protons. So like this you can tell. Got it?
Yeah.
The isotope X1 beta emitter that decays to stable isotope X2. Describe how nucleus X2 differ from a nucleus X1. What is beta decay? Any idea what happens in beta decay?
The whole process, or
I mean, the what happens means beta. One neutron is converting into what?
electron.
One proton plus one electron.
Yeah.
Understand?
Yeah, yeah.
Okay. Now let's say we will talk about this one. How many neutrons are there?
7.
7. How many protons are there? 5.
5.
So total you talk about mass number, how much?
12.
12. Okay. If I will say that one neutron will convert into one proton plus one electron. So in that case, how many neutrons now left? 6. So how many proton will be? 5 plus 1, 6.
6.
So it means when proton is changed, it means element is changed because number of proton decide the element. If that is changed, so it means the element will also change. Got it? So new
Mm-hmm.
one
Yeah.
has what? 6 proton and 6 neutron. So that's the difference. X1, if you talk about X1, so it has how many protons? 5. How many neutrons? 7. X2 has how many proton? 6. How many neutron? 6. So this is
Six.
the main difference between their nucleus. Got it?
Yeah. Yeah.
So how it is described? You can say so. You as I told you. Okay, B2 suggest why X2 is stable where X2 is not stable. What is the reason? Got it? So
Less
the
neutron.
yes, not less neutron. More the neutron, more unstable the nucleus is. Got it?
Mm-hmm.
Okay. Half-life of X1 is approximately 20 milliseconds. What is half-life? Half-life is a definition. So it is the time taken to half of the nucleus to decay of a given sample. Okay.
Yeah.
You can say it is
The time taken for an
time
radioactive
taken
isotope.
for half of the nuclei to decay for
Mm-hmm.
a given sample. Got it?
Yeah. For a given
Suggest
what?
one. Yes,
For a given what? Sorry.
for given
In the
sample.
depth. Uh huh. Uh huh.
So whatever the sample they have given you, the half of that sample, half atoms from that sample.
Okay.
Okay, last one. Suggest one reason why isotope with short lives are especially ha hazardous. Why? Because they are dangerous. If half life is less, it means that all the sample will decay very quickly. Yes or no? If
Mm-hmm. Yeah.
half life is less, it means the sample it will decay very quickly. When decay very quickly, it will release very high amount of alpha, beta, and gamma particles. In less time, you will find more particles, so that it's become dangerous. Got it?
Uh huh.
Okay. Now, question number 10. Can you read it for me?
Okay. Pluto is a dwarf planet. Figure 10.1 shows the direction of motion of Pluto as it follows its elliptical orbit around the Sun. Okay, point X is the point in the orbit closest to the Sun, and point Y is the point furthest away. The orbital speed of Pluto varies as it orbits the Sun. Describe how the speed of Pluto varies as it moves from X to Y and then back to X.
Okay. If we remember when we did this chapter, we said that when any, you can say the planet, when especially the planet which are far, they move, you can say around the sun, so they will make like this path. Sometimes they become very close and then other time they are far. Got it? As they come
Yeah.
closer to the sun, because sun has attraction, so they need a high speed. If their speed become less, so maybe they will attract toward the sun. To cancel the attraction, they need high speed. So when they are away, say they need less speed. Why? If the speed become more, maybe they leave the orbit. Got it? Because there is less force of attraction now when it is at a distance. Understand now? So you can
Yeah.
say at x, the speed is higher, and at y, speed is less. As the object goes from x to y, speed increases. Speed increases. And when it, sorry, speed decreases. X to y speed decreases. When it comes y to x, speed increases. So here it maximum, here it has minimum. When come from minimum to maximum, speed is increasing. When it's coming from maximum to minimum, speed is decreasing. Got it?
Yeah.
So how you define that one? So you say when it moves from x to y, speed decreases. And when it moves from y to x, speed increases.
Okay.
Got it?
Yeah, yeah.
Sure.
Yeah.
Okay, next. Explain in
Explain in
terms
terms.
of energy why the speed of Pluto varies in this way. So in terms of energy, you have to describe now. Got it? So
Hmm.
where it has maximum speed at kx or y.
X.
So if it has maximum speed, it means kinetic energy at x is maximum and kinetic energy at y is minimum. Got it?
Yeah.
But when you talk about gravitational potential energy, mean distance. For example, if something on the earth, okay, it has gravitational potential energy is zero. As it go above the earth, so it has more gravitational potential energy. If it is go above more, understand? So unless it will remain in the gravitational field of the earth, so higher the, you can say distance from the earth, higher the gravitational potential energy. So if
Here
we
we have
keep
sun.
this, yes, if we keep this thing here, so where it has maximum distance at y, so it means at
Yeah.
y gravitational potential energy is maximum, and here gravitational potential energy is minimum. Understand?
Yeah.
So as the object is going from y to x, so gravitational potential energy decreasing, kinetic energy is increasing. As the object comes from x to y, kinetic energy decreasing, potential energy increasing. Got it?
Yeah. Yeah.
But if you say total, total here and total here, that is same. If you plus this one, the answer you will get, let's say 100. So here, if you add this one, also you get 100. So the total energy on both points will remain constant.
Okay. This one is clear. Move to the second one because we don't have more time.
Okay. Which one?
This one, yeah, two. The last question in this paper.
Okay. So no problem. Here you can say that you know the rule.
Yeah.
Okay. Degree Celsius equal to Kelvin minus 273. Or if you have
Yeah.
Kelvin, you can 273. So by using that one, you can find. Okay. Second one. Second one, see, this is a white surface. This is the black surface. So here they are using what? They are using idea of radiation. If it is sun here, so when it comes to this part, so this part become hot very quickly if it will face the sun. But at the same time, when it goes back, so it also cool down very quickly. Understand? So
Yeah,
if the black part will face the sun, temperature will rise very quickly. And as it will go away from the sun, temperature fall very quickly. If the white surface will face the sun, so temperature increase, it is slowly. And if it will go away from the sun, even temperature will decrease slowly. Understand?
yeah, yeah, yeah.
So like this they are talking about.